Today we're going to be talking about choosing a factoring method. So we're going to be using all of the methods we've learned so far. Let's tell whether the polynomial is completely factored, and if not, let's factor it. Well, 5x squared, there's nothing we can do to factor this, and x minus 1 is already factored. So we're going to say, yes, it is completely factored. So let's move on to this next one. This one will probably make a little more sense. We have 4x plus 4 times x plus 1. So, for instance, let's look at this. 4x plus 4, you can factor that. You can take out a GCF of 4. So let's go ahead and do that. Let's take out a GCF in both terms. So if we do that, we are left with x plus 1. And we have to put our 4 in front of it, and we still need to bring down our other set of parentheses. Now I don't see any more common factors, and I'm done. Okay, so now probably the first one also makes a little more sense. There were no GCFs we could take out there. There were here, so we could factor it a little more. Let's take a look at this next one. 6x minus 4, we have a GCF of 2. So let's go ahead and take out that GCF of 2. So we are left with 3x minus 2. Now that GCF has to go in front, but you've already got 3x squared there. So, and that's being multiplied. So let's go ahead and multiply that out. So we have 6x squared times 3x minus 2. Okay? And now that is completely factored. There are no more GCFs to take out. Let's look at this next one. X squared plus 1 times x minus 4. Now you might be tempted to say, wait a minute, both of these terms are squares, but they are not the difference of two squares. We've got an addition sign here. That is not a difference. Okay? So we cannot factor that. In fact, we can't factor it any more than it already is factored. We don't have a GCF in either set of parentheses. So we're going to say, yes, it is completely factored. Now, the next thing we're going to do is factor each polynomial completely. And it says check your answer. We'll check maybe one or two, and then I'll leave the rest to you. Now, is there a GCF here? Yes, there is a GCF of 2. So let's divide everything by 2. And we are left with 5x squared plus 24x plus 16. And put our 2 in front. And now we want to ask ourselves, can we factor what's in our parentheses? And let's try it and see. We need to keep the 2 right where it is. But now, this is of the form where you have a number other than 1 in front of your x squared term. So we need two numbers that multiply, and I'm just going to abbreviate multiply to give you 5, like 5 and 1. And we need another two numbers, say, that can multiply to give us 16. So don't forget your x's there. So let's put 4's in. Let's try that and see if it works. Now remember this kind? Connect the inner terms. 4 times 1x is 4x. Connect the outer terms. We get 20x. Add them. Do you get the middle term? We get 24x. Yes, that is the middle term, so this is our answer. Okay? Now, if we wanted to check that, what we would do, let's go ahead and distribute the 2 through the parentheses. So I'm going to check it right here. So we end up with 10x plus 8 times 1x plus 4. And now let's FOIL this out. 10x times 1x is 10x squared. 10x times 4 is 40x. 8 times 1x is 8x. 8 times 4 is 32. And so we end up with 10x squared plus 48x plus 32, and that does compare with our original polynomial. So yes, it does check. Okay, so that's wonderful. So 2 times 5x plus 4 times 1x plus 4 is our completely factored answer. Let's move on to this next one here. Let's see if we have a GCF. We have 8x to the 6, y to the second, minus 18x squared, y to the second. GCF. The GCF is, let's see, we have GCF of 8 and 18 would be 2. Of x to the 6 and x squared is x squared. Of y squared and y squared is y squared. So let's divide everything by 2x squared, y squared. Now when we do this, we have 4x to the 4th, that's what we're left with, minus 9, and it looks like everything else cancels. And I should have left a little more room. I'm going to rewrite this so I can put my GCF in front. 2x to the second y squared times 4x to the 4th minus 9. Now, can we factor this some more? Look at this. This is the difference of two squares. What do you have to square to get 4x to the 4th? 2x squared. What do you have to square to get 9? 3. So we can write that as 2x squared plus 3 times 2x squared minus 3 and put our GCF of 2x squared y squared in front. And there we have it. Now, you might be asking yourself, why are we learning to do this? We're going to use this factoring later on to actually solve these equations. Okay, but you'll see this a little bit later. And if you're wondering why, this is what we're going to be doing. It's a method we use to solve equations. So let's continue. Let's go on to our next page. Now, we have 3x squared plus 7x plus 4. So let's set up two sets of parentheses. The reason I'm doing that right off is because I noticed there's no GCF. We're going to need two numbers that multiply to give us 3, and another 2 that multiply to give us 4. And let's put our x's in. Well, 3 times 1 gives us 3, so let's use 3 and 1. Let's try 4 times 1 for 4. Notice everything's positive, so we can keep everything positive in our factoring. We want to connect the inner and the outer terms to see if this works. So we have 4 times 1x is 4x, and 3x times 1 is 3x. Add them together, and we do get our middle term of 7x. So our final answer is 3x plus 4 times x plus 1. Those don't have any other common factors, so we cannot factor it further. And it is indeed the final answer. Now, this next one here, we have 2p to the 5th plus 10p to the 4th minus 12p to the 3rd. What do we have for a GCF? Well, 2 will divide into each term. And p to the 5th, p to the 4th, p to the 3rd, the one with the smallest exponents, p to the 3rd. So our GCF is 2p to the 3rd. So we're going to divide by that. And we are left with p squared plus 5p minus 6. And we'll put our GCF in front. And now let's see, can we factor this result? And yes, we can. This is one of the polynomials where we set up two sets of parentheses, and we don't have a coefficient other than 1 in front of the p squared, so we're just going to put p's in there. And we need two numbers that multiply to give us our last term of negative 6, but add to give us our middle term of 5, or 5, the coefficient of the middle term, which is positive 5. So let's try something out. How about if we use 6 times negative 1 That does indeed give you the last term of negative 6. And 6 plus negative 1 does give you the coefficient of the middle term of 5. So we can use plus 6 and minus 1. And then be sure to bring down that GCF to put in front of it. And our factored form is 2p to the third times p plus 6 times p minus 1. So 2p to the third times p plus 6 times p minus 1. Okay? Now, this next one, GCF, is 2. So let's take out the 2. And we are left with, we'll put the 2 in front of the parentheses, x to the fourth plus 9. That is not the difference of two squares because we have an addition sign between these two terms. There is no other GCF. There's nothing more that we can do to factor this. So that is completely factored. Now let's move on to our last problem. We have x to the fourth minus x squared. GCF, in this case, is x squared. So we're going to factor that out, divide by x squared, and you are left with x squared minus 1. Put the GCF in front of it. Remember, x squared divided by x squared is 1. Anything divided by itself is 1. Notice the result is the difference of two squares. All right? So we're going to set up two parentheses, put the x squared in front, the GCF. Ask yourself, what do I have to square to get x squared? That would be x. What do I have to square to get 1? That would be 1. Put in your plus and your minus. So you end up with a final answer of x squared times x plus 1 times x minus 1. And that is factored form. Again, the way we're going to be using this down the road is we're actually going to use this method to solve equations, such as, say, for instance, if I had x to the fourth minus x squared equals 0, we would actually factor this, this particular polynomial and then set each factor equal to 0. I don't expect you to remember that right now. The only thing I want to do is just let you know we are going to be using this. It does have a very practical use. So thank you very much for joining me, and we'll see you next time.